we move to our next session now with the next keynote speech from Romano HOOFMAN, the Strategic Development Director from imec. I guess most of you are aware of imec. Here is Romano coming. So we are switching from Romeo and Juliet to semiconductors. So Romano, the floor is yours.
Good. My talk will be different, but don't leave all the room. It will still be interesting. So I will tell a bit about EUROpractice, how you can make chips, how you can easily design chips. Because in the end, without chips, there is also no AI. Yeah? That's really important to know. It's not only about the software, it's also about a piece of hardware. That's the clicker. So, chips are everywhere. You know that it's not only needed for AI, but also, for instance, in your iPhone or in any other phone, there are multiple chips. Even in healthcare, more and more chips are being used. So here you see on the top right a picture of a pacemaker in which there are a few chips embedded. Then even in your passport, there is a passive chip to identify who you are and some more data, fingerprints even. And then in the car, this becomes a bit computer on wheels. It's really full of chips nowadays. So why is it important to make your own chip? Because you could buy a chip from Qualcomm or NVIDIA or Renesas or any other company. Why is it important to make your own chip? Typically, the ones you can buy off the shelf are just designed to serve a lot of people, a lot of applications. But if you want to make your own chip, then you really can get an increased performance, also higher integration rate, so you can combine different functions on the same chip. You can lower the cost because you are only putting the elements in that you want to have for your application. And also very important, you can reduce the power. And power consumption, especially if you have wireless devices or devices that are in your pocket without powering, then of course it is important that they live long. So in the end, ASICs are really a business differentiator. And why is it then important to lower the barrier to chip design? So typically it's not so easy for universities or small companies to get access to all the tools and technologies that you need to make a chip. Typically, the chip design is very complex, and it becomes even more complex if you go to the newest nodes. So currently, TSMC has 2 nanometer in production. I can tell you that's not an easy process to design a chip in. And also for universities and startups, typically the tools, technologies, and the IP are very restricted. So it means they don't give you access. And then, of course, the chip manufacturing is expensive. So we need to find a way how you can share the cost or how we can find ways to lower the cost for you. So then in the third point is that we need extensive support to give to the people to keep their design flows up to date. And then the last point, and that was already addressed yesterday a bit, talent. It's not so easy to find the right people, the skilled people who are needed to make those chips. So this we all try to tackle in an initiative that we call now EUROpractice, but it actually was not launched as EUROpractice, it was launched as EuroChip. This was in 1989, and that's the year that I started my university career, so you can calculate how old I am. But in that time I didn't know anything about chips because I'm a chemical engineer, by the way, so you see that even from chemistry you can end up in the semiconductor industry. So this program, EuroChip, was launched by the European Commission in that time to revive the semiconductor industry. So you could call it a bit, the Chip Act of that time. And they launched EuroChip because they wanted to get more engineers into chip design and fabrication. And there were 3 pillars that were actually important. So that was training, access to design tools, and access to fabrication. These are still 3 pillars that we currently do under EUROpractice. So since 1995, we are operating under the brand of EUROpractice, And we serve multiple universities, research institutes, and spin-outs of those institutes in Europe. So what do we do? You see the map of Europe, so you see many dots, also quite some dots in Greece. These are all universities and research institutes that EUROpractice, so we support with different pillars, as I said. So the services that we provide are we give you access to the design tools, that's the one on top, the blue one. Then the orange one is we give you access to also make your chip eventually in really commercial technologies. And we train you, and we also give like low-level webinars to get you up to pace with new tools and technologies that you want to use. And it's important to note that we only offer and give access to industrial-grade technologies. And it's important to say that because typically there are many other initiatives that what I call give access to a garage box. But you don't want to have access to GarageBox, you want to have access to the tools and technologies that the big players use. Because those players are having a big market share, and of course you need to have access to the same technologies to play a role in the industry. So that's what we do, and since you will use the same tools and technologies, you will also be able to collaborate with those players, with this industry. I said already that we train then, of course, indirectly the EU workforce. We support EU innovation because, well, as I said, you can work together really with state-of-the-art technologies. And then a very important element, we also stimulate and we help that universities create spin-outs, so startups that can then conquer the market with those tools and technologies. So now I will briefly highlight the different elements of what we offer to the universities, to the startups, etc. So these are the design tools. It's important to see that you see at least for the people who are in the area, they will recognize quite some logos. So you see Cadence, Synopsys, and Siemens. Those are, you could call it the big three players in EDA, so in the design tools space. But you can see also some other logos more in the area of photonics and in MEMS, which we also provide to you for making designs. It's important to note that you can only do non-commercial work with those licenses. So if you would ever want to commercialize it, so you create a spin-out, but you want to take some of the work that you did at the university in that spin-out, then we can help you to what we call commercialize your initial IP or your design. So that's what we call a subsequent commercialization agreement with one of the vendors that you will have to do. Then if you move to fabrication, so here again for the people in the field you will recognize a few logos. So the big two foundries are TSMC and Global Foundries that you see behind me. So they are producing electronic ICs for the majority, although Global Foundries also has photonics. And then you see also some smaller foundries, predominantly in Europe. So you see XFab in Germany, but they also have fabs in France, Malaysia, and the US. And then you also see AMS Osram, so that's Austria Microsystems. But they have now merged with Osram. They do typically older technologies, but still interesting, I would say, for universities to play with. Then we have compound semiconductors, so these are elements like silicon carbide, gallium nitride, silicon germanium, indium phosphide. This we also provide to you to make more simple chips. Then MEMS, already mentioned. Then photonics, it's quite a big offer that we currently have. Microfluidics, thin film transistors, so these are transistors that made on foil. This is actually only NMOS, so you cannot make a CMOS device with it. And then the last one, which is not on the map, is graphene. There are more and more efforts also coming with graphene, so this we also offer. And then if you see, I was mentioning that typically fabrication is quite expensive, so we can help you to offset the cost. So we organize on a regular basis multi-project wafer runs. And this is actually that you share your design with other customers' design on the same wafer, on the same mask set. So you not only share the cost of the wafer production, but also the cost of the mask set and what is needed for that. So in the end, you can really lower the cost considerably. But that is not enough, so we do that typically also an MPW of an MPW. So then to give you an idea, for instance, if you would like to make a design in 28 nanometer TSMC, then we can give you 1 square millimeter area for 8,000 euros. So that's the price, and for that you get then 50 to 100 dies on the table. These were the statistics of last year. So last year we fabricated 837 designs in silicon for universities, startups, and different entities all over the world. And you see here the division of the different technologies in which they are made. So where is Greece? Greece needs to step up, I believe, because there are some tape outs happening, but you can see you're not the leader of the pack. So you can see Germany is really the #1 with the most tape outs, then followed by France and Switzerland. And Switzerland is maybe not so fair because a large part is coming from CERN, so the nuclear institute, or with their big accelerator. But still, yeah, and then Belgium, United States, etc. But Greece, it's on the low side, so it's even less than 10. So I would really urge the universities, research centers to pick up the pace. And as I said, it is not that expensive to make a design. And if you really want to play a role there, and this we can do together, so this is a reach out to you. We also have training, so if there are not sufficient people who are able to make a design with the state-of-the-art design tools, then we can also provide training for you. So you see here on the pie chart that you have both analog and digital IC trainings, but also hardware descriptive languages, more and more courses or more technology courses. And typically those courses are hands-on, so we invite people to play with the tools and the technology. And they will, of course, contain examples from the design tools and technologies that we offer in the portfolio. Typically, the trainings are 2 to 5 days. So an example of that was a summer course that we did in Leuven. It was 5 days introduction to IC design. And you can online book, so see if there is availability. And yeah, if you're interested for a course that you don't see on the schedule, because there is the website, so you can really find there the different courses, then you can send me a mail and we'll see whether we can organize a course for that. So these are 2 examples. So you see here on the left-hand side a classroom training. So this is more plenary, so that's not the hands-on part. The hands-on part you see actually on the right-hand side. So you see that every student has a laptop, and now we have also increased our facilities, though they also have a bigger screen, because typically for design you want to have a bigger screen. Working on a laptop screen for 3 days or so in a row is not a pleasure. So it's much better now. These are 2 pictures taken in imec, but we also do this in our partner institutions in the UK, in Germany, in France, and in Ireland. So what we have coming soon for maybe people who are interested in state-of-the-art technologies, this is the N2 PDK, so this is the 2 nanometer PDK that we have developed in imec. So it is unique because this is even what you don't find in the TSMC foundry yet. So it is based on nanosheet technology that is already in production in TSMC. But in addition, we have also what they call backside power delivery. So it means that the power lines are coming from the backside of the wafer, and from the front side is the signal routing. So you can learn a bit how to deal with those, I would say, advanced concepts, which will give you a head start once this comes into production. So this we developed under a project called NanoIC. So this is one of the EU CHIPS Act pilot lines. So for making this happen, we got 1.5 billion euros from the European Commission plus from the Flemish government. You see that is a consortium, so we do this together with CEA, Fraunhofer, Tyndall, VTT, and then the Politecnico in Bucharest, in Romania. And the mission of the project is actually to explore sub-2 nanometer devices. But not only that, we also do novel embedded memory devices and also future interconnect options. And also those technologies we want to make available to you, not always, I would say, in a way that you can fabricate it, but at least what we call that you can do design exploration. So we give you access to PDK so that you can get acquainted with those technologies already. So this was a pilot line, and you see there are more pilot lines. So also CEA has one, which is called FAMES. Apex is the one from Fraunhofer. Then you have PIX Europe, which is more on photonics. And then there is also wide bandgap material from Italy. So these are the 5 pilot lines. And then there will also be 6 quantum initiatives. So that's the one that you see there next to the pilot lines. And then there is the design platform. And the design platform, that's a new initiative that I'm heading. And you see there is the connection between the pilot lines. So we want to give users access to the design platform so that they can make designs in the technologies of the pilot line. But more importantly, we also want to do this connecting to the commercial foundries. So you can call it a bit a EUROpractice on steroids, because we want to do this for the entire industry. And then eventually we foresee that EUROpractice will merge into the design platform. And then you see there the white box on the top right. There you see the skills initiatives and the chip competence centers. So also Greece has a competence center that was presented this morning. So it's really important also to make the connection there. And in my final slide, I will also reach out to you to see how we can help each other to grow each other's industry. So then a few words on the chip design platform. So that's what I called the EUROpractice on steroids. So it's a rather new initiative. We started only on the 1st of January of this year. And we do this to follow actually the objectives of the European Commission. So you see that what comes back is what I showed on my first slides. So we want to lower the barrier to IC design, and in particular for advanced technologies. We want to foster collaboration so that people, stakeholders, can really work together with each other and that we can grow the European industry together. We will support the development of IC design skills by offering training and support services. And this we do together with the Competence Center, so also together with the Greek Competence Center. And then we will integrate also access to the pilot lines, but more importantly, I would believe, is the access to the commercial foundries. So the TSMC, Global Foundries, and all the logos that you saw on my previous slide. And we will leverage and build upon existing platforms. We don't want to reinvent the wheel. We really want to start already with a head start, to call it. And the overall goal is to develop a cloud-based design infrastructure where you can find virtually everything. So the design tools, the IP, the PDKs, anything that you would need to make a design for your product. This is the high-level concept. So you see in the middle box, design tools and IP, and it's both commercial and open source. So in our central cloud infrastructure, we want to give access to open source. Of course, there is already a lot available on GitHub, but there is not such a place as a one central place where you'll find everything combined. So that's what we are trying to make the place to go. You could call it the one-stop shop where you will find everything for chip design. And this will be made available in a really enabling design environment. And then you see, of course, the training and the support, and importantly, the users who we really want to bring in. So there also we need your help. We need also Greek startups who will make use of the design platform. So how does it look from top down? So currently, we have the platform coordination team in place. So we are responsible for coordinating the design platform, for setting it up, but also for developing mentoring and startup programs. So that is something we are now developing. We also want to link with the pilot lines and the competence center. We are negotiating, and that's an important element, master agreements with the EDA vendors so that early startups can really get low-cost access to those EDA agreements. So that's what we are trying to do. And for Siemens EDA, we are almost there. Then select onboard and integrated design enablement teams. That are the ones that you see in the blue box. They have been announced. So we have now 9 design enablement teams, geographically spread over Europe. Not in Greece, unfortunately, but as I said, startups from Greece can, of course, use the other design enablement teams because there will be a design enablement team that is focusing on TSMC. There will be another one on Global Foundries, and of course, you can go there to get design support and get your product fast to the market. Because in the end, the design enablement teams, they will provide the environment for you to make your design together with them. So they will have already pre-set up a design environment, and they also give you the support that you need. And more importantly, they also will provide and manage the supply chain that you will need eventually once you are on the market, that you have a steady stream of volume of your products. So how it looks like in a bit more detail, so this is a bit summarizing, I would say. So we want to make available open source EDA and open source IP, but also the commercial and the EDA and IP. We also want to provide a training sandbox environment in the central cloud so that you can play around and upskill yourself in chip design. And then very important, we are developing these startup programs to mentor startups and really give them business training. And maybe the most important element is really to bring them in contact with the investors, with VCs, other private investors, so that the goal is to get at the end of the startup program that they have new capital and that it can easily scale up. And then you see there a big pick, and that's important to mention. So the European Commission has put 220 million euros in that pick to support 100 startups with. So for this money, you can get offsetting of the license cost for the EDA and IP. You can fabrication cost, the design support that you get, packaging and test. So it's quite a big package. And it's intended that the member states, so Greece, the other countries, also put another 220 million in the PIC. So in the end, we hope that that PIC contains 440 million euros for supporting 100 startups. And for that, it can then support 70% of the total cost of a startup program, so a project. So that's quite considerable, and that's something that you need to promote in Greece as well. So how does the chip design journey look like in our chip design platform? So you start, or there could be a very early startup could start in the orientation phase. So that means where we need your help from the Greek Competence Center, because that's the time that the startup will make the choice for tools and technologies that he will use to make his chip, because maybe early he will not know yet, do I need to go for a 40 nanometer or a 28 nanometer? Do I take Global Foundries? Do I take TSMC? That's something where you and well, the platform coordination team together can help. Then once they know that, then they move into the startup program, and then they can physically make the design together with a design enablement team of their choice. And we have two pillars. We have an incubation and an acceleration. The incubation is for the very early startups, where we really try to train them both on the business side, to shape their go-to-market plan. And of course, this we'll do together with industry experts. So also there, I would say, you can help us if you really have industry experts in Greece that would like and have a passion to grow startups together. Then let me know their contact details, then we can make them as a mentor in the startup program, because that's, we in the end want to have around 100, 200 mentors that we can then use for the different startups. And you see that eventually the goal is to go to the end, to go to production. In that phase, we say they are graduated for the design from the design platform, but they still use the design enablement teams for the prototyping, or for the products and the volume that in the end they will do. So that's a bit the journey of a typical startup. And how can you help? So how can the Greek Competence Center help? So you can help with creating awareness and advocacy. So you can reach out via academia and research centers to really create startups, and even through the technology transfer offices at the universities. So to make them aware that we have this initiative and that we have these two big pigs there, the 2 times 220 million, that we have the startup program so that we can also help them to make their business successful. So that's one thing you can do. Then you can help us also to give a general orientation of the startup. So as I said, the mentoring and the training, and then structured orientation as well, so that it is more about business support. And then once they are out of that funnel, they are in the design platform, and then together we will hope that we can make it to a success, so that more startups are generated and more startups become successful on the market. So what is the timeline? So very quickly, so the website is in place. So if you go to eurocdp.eu, you will see it. But it's a very low version. We are now busy on making a mini marketplace. So the mini marketplace will summarize the services and the tools that we have already in place. Then we foresee that by the end of next year, we will have a fully operational central cloud with these training sandbox environments, etc. Then if you look to open source, so there we will probably launch that already early next year. But the EDA licenses, we hope to announce the first agreements with Siemens EDA and Keysight in the coming weeks. At least I really hope so. And Cadence and Synopsys, they are a bit behind, but I also hope that they will come very soon. As I said, there are 9 design enablement teams selected, so now we are reaching out to them so that we can integrate them in the design platform, and we hope to get them operational somewhere Q1, Q2, so that there the startups can already go to make a chip. Then the first launch, or cohorts as you call it, in startup programs, we will have somewhere Q2 of next year, and then so the launch of this big pig will probably be in March, April of next year. So that's the timeline. And this is the team, so these are the people behind it. This is not complete set, but these are some people who are trying to build this platform for Europe and to make the startup community a success. That concludes my talk.
Okay, any question for Romano?
I have a couple of questions. The first one is a little bit technical. Out of curiosity, the 2-nanometer technology node, does it refer to the channel length or any other pitch, or is it just an arbitrary number?
No, it's the channel length has been abandoned already many nodes before. I think that was probably maybe 40 nanometer or no, I don't know exactly. At a certain moment they decided they did all kind of things. I mean, they went from silicon oxide to hafnium oxide, so to high-K dielectrics. That already, I would say, made that the channel length was not really the physical channel length anymore. And then now we have, you can call it gate-all-around devices. And then, of course, you cannot talk about the channel that much anymore. So we speak about a physical channel length and an effective channel length. So they are decoupled now completely.
Okay, thank you very much. And my understanding is that the EUROpractice and the pilot lines have similarities with the foundries. Maybe I'm wrong, but I find some similarities. There may be also differences. Can you say what are the big differences between, let's say, EUROpractice and other foundries like
well, I will start with EUROpractice because that's the easiest. So EUROpractice, as the chip design platform, provides access to both pilot lines and foundries. So we are not a foundry, we are not a pilot line, but we provide access to those entities. So we help you to make a chip in those technologies. So actually we submit the design for you to the foundry. Then they start to make the chip, we get the chips back, and then we send the chips to you. That's how we work. The difference between a pilot line and a foundry is typically maturity level. So pilot lines should work on technologies that are now not commercially available, So in imec we work now on sub 2 nanometer, but of course you cannot fabricate those yet at high yield. So that's why for the sub 2 nanometer nodes we call what we make available design pathfinding PDKs. So you can get knowledge of how to make a design in those technologies, but we cannot fabricate it for you. We could, but the point is that it has so low yield still that you will not have a functional device.
Okay, thank you.
Yeah. Any other question?
Yes, any other question?
Thank you very much for this very nice presentation. My question is beyond, let's say, pure silicon. Do you offer any services for multi-chip packages, for chiplets and stuff like that?
That's a good question. I didn't show that. So we also offer what we call standard packaging solutions for universities and research centers. So typically 1 out of 3 of the projects that we do also receive a package. Typically you don't need to package all 50 dies that you have, so typically university goes for maybe 10 of the dies they also get packaged. Then the other question about if we also do chiplets or interposer technology, we can in principle offer everything. The point is that it is quite expensive. So most universities will not be able to pay it because we have to go for dedicated solutions. And it's also not so easy to do this at low volume. So if you would have a startup, then of course there is a projection for the volume. And then we can easier talk to big companies like ASE and Amcor. But if you would knock on the door of ASE yourself, you have no chance if you say I want 100 samples packaged.